So whether it's 220 or 230, your content is the same for the test, and you only have the one test for the semester. So you're either taking it for 220 or 230 at the beginning of the semester. So you won't have to take another dosage calc test, at least not one that is where you're getting the 25 questions. You can miss two uh, scenario. You're getting and then have to remediate. You will get, I think, for 230, if that's when you do your pediatric section, you'll get a pediatric dosage test. At least Allegheny campus does that. And so, but it's not the same type of test like these dosage calc tests that I'm reviewing for. So just in case, I always like to clarify that because I always get students asking me the difference between 220 230. There's definitely a difference in the classes, but there's not a difference in the dosage calc test that you're taking. So you're responsible for knowing a lot of the same things you have done already in 110 and 130. You have to know how to do your household measurements, so metric to metric, household to metric, and then even some household to household. You need to know how to convert pounds to kilograms. You're going to need to know how to calculate the amount of fluid intake. So they're going to give you the patient, what the patient ate for lunch, and you need to convert what they ate for lunch in, teaspoons, tablespoons, cups, ounces, quarts into milliliters. You're going to do your oral based medications, so you need to know how to calculate, to get to tablets, capsules, or milliliters. Your parenteral medications, remember, if it's being injected, it has to be liquid and it's going to be milliliters. The only exception to the parenteral medication milliliter unit that you're solving for is that if you're dealing with insulin, remember insulin is measured and administered in units, not milliliters. Okay. You're going to see some more flow rate questions like you saw last semester. So those are, calculating milliliters per hour, how long is an infusion running, and calculating your drop rate and then getting to drops per minute. And then what I'm going to talk about specifically today is going to be the heparin questions. So the heparin bolus calculation as well as heparin infusion calculations. The heparin infusion calculations are very similar to the flow rate questions. It's just that in the infusion calculations, a lot of it is asking you to convert units per hour to milliliters per hour. So I'll actually start with that because that helps us to kind of weed ourselves into the bolus calculations. But you'll see the examples here, and it'll make sense. And then I think there's at least one or two nitroglycerin examples, so we'll go through those as well. So I'm going to go ahead and pull up and switch my share to the review. So I renamed the review. There's actually quite a few reviews listed on in the shared OneDrive folder that you guys have access to. The one that looks like this, and I'll upload after today the 26 spring, which is the same as the 25 spring review. The other one I is like an AI review that I did over the summer. I don't know if that was any better or not. I had Gemini try and create some alternative questions. I didn't really get much feedback on it. I honestly didn't look at it thoroughly, other than to add in a few of the labels. So, but what now I think she's in practice. Maddie Kessie put together this review a couple semesters ago, and it's a pretty solid review. And because I don't have any other review material for you guys, I don't know if you guys get other review material, but if you ever do, please feel free to share it with me, and I'm happy to go over it with you. So make sure you know your conversions. I think everyone's pretty good about that. This is just additional practice. So I'm going to get to the heparin stuff. I'm going to start there, and we can always go back if there's other questions that we need to look at. All right. So when we get to the heparin questions, there's a variety of questions that you might get asked. You might get asked basically a two-part question where it'll ask you in one question, it'll ask you to calculate a bolus and it'll ask you to calculate an infusion rate. So I'm going to show you both those things and how to get to that with these examples here. And then we'll practice a few together and I'll have you kind of solve on your own and you can put your answer into the chat box and then we can kind of go from there. So we'll start with this first one here. Um, and really the big difference or the things to pay attention to is they're going to ask you to do a couple things. They want you to convert the patient's weight in pounds to kilograms if it's not already done for you. Typically, you're going to round that pounds to kilograms to the nearest tenth. There sometimes is some nuance with that. So you always want to consult with your instructor, like especially for this type of question where you might be rounding twice. Usually that can be considered a no-no, but it should be fine because of whether you round or don't round your weight it typically comes out with the same answer no matter what you do. I've always been taught to round the patient's weight from pounds to kilograms and then solve, but consult with your lab instructor, the one who's grading your test. If there's any kind of nuance, just make sure you know what that is, and do the rules according to what they say. All right. So, um, we're going to do some calculations. Some of the stuff is pretty like you'll see that it's not too terribly difficult, but it's helpful to know like how to work the information. So it tells you that you're supposed to bolus the patient with 80 units per kilogram body weight, and then to start a drip at 18 units per kilogram per hour. Now, I was actually just mentioning this to the 130 class, and I mentioned this to the 230 class for Allegheny campus when I was doing these reviews yesterday. And I told them they're going to call it a drip rate or a drop rate because it is coming down really slow, but you're not calculating drops per minute. Okay. And the reason I know that is because there's no drop factor listed. It doesn't say anything about any tubing, microtubing, anything like that. So no one's expecting you to just kind of create a wild guess of what the tubing is. So they just want you to understand that it's coming out real slow, like, 10 mil per hour, which is, 2 teaspoons per hour. It's pretty slow, right? That's coming out real slow. It's dripping. And that's why it's called a drip. Anyways, so in this scenario, we're given our protocol. This is our order. We're gonna bolus the patient with 80 units per kilogram, then start an infusion rate at 18 units per kilogram. It gives us the patient's weight. It's also going to give us what's available. And what's available is 25,000 units, 250 milliliters, half normal saline. So that's our IV. We also have a bolus dose strength of 1,000 units per milliliter. So we need to know both of those pieces of information in order to answer this question. So the first question is, what is the milliliters for the bolus? Okay. We don't want to know the units for the bolus. We want to know the milliliters for the bolus. So this has already been figured out for us. So 178 pounds, rounded to the nearest tenth, we're going to get 80.9 kilograms. So what I'm going to do is I'm going to take the 80.9 and I'm going to multiply by my order of the 80 units per kilogram. Now, I can set this equal, find out what the units are, and I think that's what I'm going to do this time around. But that I'll probably work through it again and I won't do it this way. So you can either just set up your next conversion and convert units to milliliters at this point, which is what I typically do. Or if you want to set it equal, you can set it equal, whatever's convenient for you. So I'll actually do it I'm going to do it the way, I'm just going to do it the dimensional analysis way. Um, just because sometimes it's helpful, like before you get into too much calculation, it might be helpful at least to know, um, that you've set up everything right into your calculator before you kind of plug it in. So I'm looking for milliliters, so I don't want milliliters. Or I mean, I don't want units. I want milliliters. So I need to know, can I convert units to milliliters? And I can because I have two available pieces of information. I have units to milliliter relationship here, and then I have 1,000 units per milliliter relationship here. The question is, which one do I use? Well, if we're calculating the bolus, then I'm going to use the bolus information. So 1,000, 1, and then I'm going to plug that into my calculator. I'm going to take 80.9 times 80 divided by 1,000. I'm going to get 6.472, and I'm going to round that to 6.5 milliliters. So that's how you would calculate for a bolus dose for the heparin protocol. For the infusion rate, we're going to do basically the same thing. It's just that we're going to use the different data points. So we have the patient, 80.9 kilograms. And we're going to multiply by the infusion rate. And then you can see that the infusion rate is this 18 units per kilogram per hour. And what this is going to do is get rid of kilograms. And again, I'm just going to do the conversion part. I'm not going to set that equal. I kind of bounce back and forth depending on the review. So if you want to see me like, set it equal and then do the next conversion, I'm happy to do that. Just let me know in the chat. Otherwise, like you said, you can look at previous reviews and see where I've done where I've set it equal and then moved on thing. This we're just gonna do it this way today. Or at least right now until someone tells me otherwise. All right. So I need a way to convert units to milliliter again. So if I set everything out up right, I'll be in milliliters per hour, which is what I'm looking for. Okay. Um, but what I need to know is which milliliter per unit relationship or available do I use? Do I use the bolus or do I use the IV? And if we're calculating the infusion rate, this is what they're connected to. So this is the 25,000 units, 250 ml half normal saline. That's the information we want to use for calculating our flow rate. So the 25,000 units goes down here. The 250 ml goes up here. And we're just going to go ahead and we'll solve for this. So I'm going to take the 80.9 ml or kg, I'm sorry, times 18 times 250 divided by 25,000. I'm going to get 14.562, which we're going to round to 14.6 ml per hour. Does that make sense? Okay. So like I said, that's the big difference. That's the big difference of what you're like the new thing that you're seeing if you haven't already been exposed to this or you haven't already practiced these. That's the new thing. And the big and like you're gonna see some questions down here. Let me just find one real quick. Like this one here. It's gonna tell you um you're basically going to be doing what you've done before with flow rate, but um instead of calculating um oh well never mind. This is not even like this is just calculating a bolus. Okay. So you're gonna take your 25,000 units is the order. Your available is 10,000 units per milliliter. You've done this before. This is just 25,000 divided by 10,000, and then you'll get your, I think it's 2.5 milliliters as your answer. The example I was looking for was something like this, where you are either converting units per hour to milliliters per hour or milliliters per hour to units per hour. So you're just doing a conversion. So like for this one, you have a couple pieces of information. It's just like the heparin protocol. It tells you what's in the IV. So this is in their IV, the 20,000 units and 500 milliliters. It's infusing at 50 mil per hour, and it just wants to know what would that be in units per hour. So if we're solving this, what I typically recommend is, or I should say, the shorthand is we're just going from one flow rate to another flow rate. We're just making a conversion. We're converting miles per hour to kilometers per hour. We're converting ml per hour to units per hour. So this is where feeling pretty solid about dimensional analysis really helps out with questions like this. So I typically start off with the 50 mil per hour. And then I ask myself, what am I trying to do? I'm trying to convert milliliters to units. And I can because in my IV, I have the 500 milliliters and I have 20,000 units. So I cancel out milliliters. Before I do any math, I'm already in what I'm looking for, which is units per hour. So again, I'm just going to take my calculator, 50 times 20,000 divided by 500, and I'm going to get 2,000 units per hour. I'm going to do the exact same thing here, but in this situation, I'm going in the reverse, right? So I have my IV. So that's what's in my IV. This time, though, it gives me units per hour, and it wants to know what will the IV pump be set to. What they're asking is, what is the ml per hour? So again, I'm going to start with the flow rate. I'm going to convert units per hour to milliliters per hour. So you'll notice that I'm switching the position of the ml and the units. And again, the thing that helps me to visualize that is by writing it out. Okay. When I do this, I like type it into my calculator when I'm plugging in these numbers. I don't write anything out. But me telling you that I just set it up like this and just plug these things into my calculator, I don't think that helps you out. So I just like to use this as a visual so you know where things go. And if you're like me and have a history of multiplying when you should divide or dividing when you should multiply, this helps to eliminate that. Okay. Not 100% foolproof because you still need to know how to set it up appropriately, but it's helpful, right? I'm not guessing where that 500 came from. I'm not guessing where that 20,000 came from and why I'm plugging it in next to units or the 500 next to the ml. I'm just arranging this so I can get to my answer, which is what I'm looking for, which is ml per hour. The other thing I mentioned and why I box this and say it's the IV, it helps to remind you to keep this together. Okay. So whether we put the units on top or the milliliters on top, we just need to make sure that we keep those two things together. Okay. When you're doing that, just in case it's been a little while since you've been told that. So, all right. Anyways, I'm going to take the 500 or yeah, 500 times 1,000 divided by 20,000. And I'm going to get a nice simple 25 ml per hour, which should make sense because if this was 2,000 units per hour here and it was 50 mil per hour, then if this is half, then this should also be half. So that also worked out. So if those of you are like, why is he spending so much time writing these out? Well, I'm writing them out just because like when they're easy and straightforward, it's helpful to kind of look at those and make sure that we're not making any silly mistakes. And then you've already rationalized and already know what the answer is. But if you can set it up, then you can solve any question like this, and then it helps to eliminate a lot of that guesswork. All right. So these are just some different variations of the infusion rates. I just want to find that nitroglycerin question, and then I'll come back and we can look at any of these if you want to. This is a very similar example to what we use at Allegheny campus, where they'll be given like all these numbers, right? So we don't care about the 0.45%. That just tells you what the 250 milliliter like percentage of that normal saline is in the 25,000 units of heparin. It's infusing at 2,500 units per hour. And the question is, what's the infusion rate in milliliters per hour? And I just showed you how to set that type of question up. All right. For the nitroglycerin drip, a lot of this is just, can you convert micrograms to milligrams? Can you convert minutes to hours? It's just asking you to do a couple extra kind of conversions in that regard. Remember, when it asks you what you set your infusion rate to, if it doesn't give you a drop factor, they're typically asking you milliliters per hour. And I'm mentioning that just in case they don't tell you outright that it's milliliters per hour. Okay. So it says your patient is starting on a nitroglycerin drip of 50 mic per minute. You notice that the nitroglycerin is mixed at 25 milligrams in a 250 ml bottle, yielding a concentration of 100 micrograms per milliliter. So that's helpful. That already kind of tells you the concentration. So you don't even need to worry about the 25 milligrams, 250 ml. It already tells you that your available is 100 micrograms per milliliter. So you don't need to worry about converting micrograms to milligrams. You just need to make sure you convert minutes to hours. So let's work through that. So what I'm going to do is I'm going to just set this up. So I have my 50 micrograms per minute. I'm going to do this kind of like the long way. So if you hate the way I'm doing this, I apologize in advance. So remember, what am I looking for? I'm looking for ml per hour. So I can use my available in order to help me arrange that so I can get rid of micrograms and convert it to milliliters. So I know 1 milliliter contains 100 micrograms. And the last little thing is I just need to make sure I convert minutes to hours. And I think most everyone can do that. You know that 1 hour is 60 minutes. So again, if you're somebody who sometimes multiplies when you're supposed to divide or divide when you're supposed to multiply, especially when it comes to converting minutes to hours and hours to minutes, it's again helpful to kind of write it out. So I'm going to take 50 times 60 divided by 100, and I'm going to get an answer of 30 mil per hour. So those are some of the examples of what's kind of new. And I find that like when I review for 230, when I review for 240, I find that my reviews are a little bit shorter and more concise because most of you guys are hopefully really good and strong on the other things. But if there's any other questions, anything you want to see another example of, let me know. I know I know I said I was going to have you guys practice some, but I have a feeling you guys have already been practicing these. But if there's one that you want to see or practice, just let me know, either unmute or chat. If you feel good and you feel like you got through all these questions and don't really have any issues with them, then uh, I've reviewed all the new stuff. So I'll leave it on you if there's something else you want to look at. Okay. Let's do. Okay, so that was the. Oh yeah, that's that. Okay, give me 1 second. Let me find a good bolus information question. All right. So for this question, um, let me just double check and make sure I have a bolus. Don't have that. Give me 1 second. Sorry. So some of these don't have the bolus, but that's okay. So what we're gonna do is we're gonna do this. Sorry. We're gonna do we're gonna do this question here, and I'm gonna add that are available. So my because you need to know that my available bolus is the 1,000 units per milliliter. So the question says, and then this is for everyone. So everyone can attempt this question. Um, and what we're calculating, so you can ignore this unless you want to do that. But what I want to know is, I want to know what is the ml for the bolus for this particular question. So, and then when you get your answer, just type it into the chat. So it tells you that you're going to start an IV drip at 12 units per kilogram per hour and to administer a loading bolus dose of 60 units per kilogram. You're supplied with heparin that reads 25,000 units per 250 ml. You're also given a bolus dosage of 1,000 units per milliliter. Your patient weighs 189 pounds, and we want to know what the flow rate. Yeah, we want to know what the bolus dose will be. And then if you calculate the infusion rate, you can type that in as well. I got one answer so far. Is anyone stuck? Right. Well, I'll say I also got 5.2 milliliters. So just in case you're stuck, we're going to take our 189 pounds. You're going to divide by 2.2. Okay, good. Let me see. Sometimes, and thank you for letting me know, Casey, what you got, because sometimes um, the issue is if we use different numbers. So let's make sure we're all using the same numbers. So I'm going to start off by taking 189 divided by 2.2, and I get 85.9. Oh, okay, yeah. So 10.3 mil per hour is probably correct for the infusion rate. But I was asking you to calculate the bolus dose. Um, so okay, that's probably what happened there. So the bolus dose, you want to use the 60 units per kilogram and then the 1,000 units per ml. All right, so I get 85.9 kilograms times 60 units per kilogram. So that gets rid of kilograms, and then the 1,000 units per milliliter, and that'll give us our 5.2 ml. So that would be, so this is, I added an additional question to this without changing anything. Now, if yeah, please go ahead and do the infusion. Oh, yes, I will do the infusion. Sorry, Karen. Yeah, so like I'm going to take that same patient weight, right? The 85.9 kilograms times, and it tells me that I'm going to do 12 units per kilogram per hour this time. And then that gets rid of kilograms. I don't want kilograms. I want milliliters per hour. I don't want units per hour. I want milliliters per hour. So I'm going to get rid of units in exchange for milliliters. So 250 ml, 25,000 units. And then that'll give me, so 85.9 times 12 times 250 divided by 25,000. And I'm going to get the 10.3 milliliters per hour, which I think is what most of you guys were getting for that question. Hour. So what you'll notice is like what, and the reason that I kind of talked about the other infusion questions. So if you look at this, once I've multiplied here, I'm in units per hour. I'm multiplying by the available in the IV to get milliliters per hour. So you're going to see like questions that are just calculating the infusion and you're just converting units per hour to milliliters per hour. So that's all that we're doing here. It's just additional practice. So I would say those other questions are kind of like that that the other questions that I previously went over is kind of like a workup step. Do you know how to make those conversions? It's really what it comes down to. Yeah, bolus never involves hours. So bolus means now, right? So like if I give a bolus dose, that means now. So they're going to get that whole thing. It's a big dose right now. That's a great question. Yeah, bolus will never involve time, because by definition, well, I guess technically you could administer a bolus dose over a period of time, but at least the way these questions are asked, that's not what they're asking you to do, and this is what because I've never seen this done, but I imagine what's happening is you have a little vial, so they're attached to the IV, they're on the heparin drip. You've already set the infusion for like the 10.3 milliliters per hour, and then you're going to go to a separate bolus vial with a syringe. You're going to draw up the bolus dose amount, and you're going to put it in the port that's going to go right into the IV, and they're going to get a big boost of heparin first, and then the rest of it's just going to titrate over the 6 hours that they're on this protocol. Does that make sense? You're welcome. Yeah, great question. Yeah, so bolus will just be milliliters. And I apologize if you didn't. I know you didn't ask for that visual, but that I like to kind of wrap my head around like, well, what's happening, and it gives me an idea of like, so if I ever get stuck with how I'm answering a question, it's like, well, what's happening clinically? You know, is this something that's titrating over a period of time, or which would involve some element of time, hours, minutes, whatever happens to be, or is this something that needs to happen now? So like, do I take the 5 mil now? um, and then administer the next 10 mil over the next hour. How does that work? Anyways. All right. Uh, yes. So technically anytime they say like a two-step problem or something like that, or a complex problem, that just means it's a weight-based problem. So like the example I have here was towards the beginning. Not that. Like this right here, like this two-step problem where it tells you that you have a patient that is the order is 3 milligrams per kilogram, and then the patient's weight is in pounds. So you need to convert pounds to kilograms, calculate the milligrams, and then solve for how many milliliters. So that would be a weight-based problem. And then I think it is on the blueprint. Let me just double check. You might be right about that. Oh, okay. I see what you're saying. Because it says the medication titration, which and then in the 130, it tells us the complex problem. So I would say be prepared for it just in case. Um, but you're right, it is not on the blueprint. So they're gonna follow the blueprint pretty good or pretty straightforward. But I added these in here just in case you have to do them because they can get at this point they can get lumped into your oral based meds because they already assume you can do it. So yeah, reconstitution, you got it. All right. So remember the big thing about the reconstitution. So you'll see, this is the example that I've used over the last several semesters. This was just pulled out of probably a textbook. I'm not exactly sure where Maddie pulled this out of, but um, when you're doing a reconstitution, the trick is you just need to know that you're dealing with a reconstitution question. So that's the thing that like sometimes will get you stuck. So like don't worry about, all this stuff up here. Let's just focus on this, and the label, and then calculating what you're going to administer. So your question is going to look a lot like what do we administer, right? Um, and you need to know that if it says intramuscular, that means milliliters, right? So if it's an injectable, it's milliliters. So you're solving for milliliters. We'll know we're dealing with a reconstitution is that when you look at the label and it just says milligrams, it doesn't say anything about milligrams per milliliter. So like you've probably noticed that a lot of the medications, the labels will indicate, something per milliliter or something per capsule when you're dealing with this. But this doesn't tell me anything about how it's administered, which is your clue that it's reconstitution, which just means you have to look in the label off to the side. You have to look at the label to get the information you need. And the information you need is actually right here. So you're looking for that milligram per milliliter example. So this just tells you what to do in the pharmacy, or what to do if you're at, at the at the patient's bedside and you're in a clinical setting where you need to add the liquid yourself, mix it up, and then once it's mixed, this tells you what the concentration is. And so once you know that, you're just gonna solve for using desired over order over available. So your order is the 0.375 grams. You're going to convert that to milligrams. So 375 milligrams. And then you're going to divide by your available, multiply by your quantity, which is one, and then you get your answer. So like I said, that I think for these, the trick is just knowing how to identify them and then how to solve for them. And then again, rounding comes into play here. So 1.7 milliliters would be your rounded answer. Yes. All right. So for a drop rate question, here's a good one. Um, so first of all, when you see a question like this, so I'll go over this, but like when you see these, you need to get in the habit of what the drop rate question is. So I always take a step back. I know you just want to kind of see it and you probably already know this, at least that's my assumption. But when you're calculating drop rate, you need two pieces of information. You need flow rate, which is typically in milliliters per hour, but it could be in milliliters per minute. And you need the drop factor. And the drop factor is going to be drops per milliliter. Those two pieces of information give you your drop rate, which is drops per minute. So it tells you the drop factor. If it asks you to calculate a flow rate and it just gives you the drop factor, that's your indication that it's looking for the GTT per minute. Okay, so if you ever like get stuck on that. Um, the other thing is if it says something about microtubing, microtubing equals 60. The drop factor is 60. Just in case you see that. You probably see that more so on like ATI than anything else. So I read my question. It says administer gentamicin 60 milligrams in 50 ml, dextrose 5% water over 15 minutes every 6 hours with a drop factor of 20. So there's a lot of information in here, even just in one sentence. Okay. So the only thing I need to know is what the flow rate is. So I need volume over time. If when you know that, no matter what they tell you here, we don't care about the strength. Obviously, we care in a clinical setting. We want to make sure the patient's receiving the right medication. But all we're doing here is we're converting volume over time into another volume over time. We're just doing a flow rate conversion. So I don't care about the strength. The other thing is that can trip you up is it says over 15 minutes every 6 hours. If I had written this out as QID, you probably wouldn't even bat an eye, right? It's just telling you to run this infusion every 6 hours. Okay. So you run it for 15 minutes, 6 hours later, another 15 minutes until you're done following that particular protocol. So we can ignore the 6 hours. So I'm going to take my volume over my time times my drop factor. We eliminate milliliters. We're left in drops per minute. And then I got to plug that in my calculator. 50 times 20 divided by 15. In this particular example, I'm going to get 66.66666 is going to keep going, repeating. And we are going to round that to the nearest whole number. So we would say 67 drops per minute. We can't give somebody a partial drop. So you can give somebody a tenth of a milliliter. That's not a problem. We have syringes for that. But you can't give somebody a partial drop. They either get the drop or they don't get the drop. Good question. Any other questions? All right. Well, like I said earlier, I'll be back on at 5 for Boyce 230. Did I say 5? I meant it's 6, right? Uh 5 is the 1:30. Let me just double check my time, just be on the safe side. Yeah, 6 o'clock for the 230 class, for Boyce 230. If you are unable to make that time or don't have any further questions, great. Just keep practicing. If you do have some questions, can't make that time, you can email me. But or you can just email me anytime between now and when you take your test next week. But if you're able to solve these questions with very little, like, challenge, and it's just a matter of just practice, that's the best recommendation I can give you, is just practice, practice, practice. um, and then ask questions. So if there's something you're getting stuck on, or you try something 3 times and you get 3 different answers, that's a great question to send my way and say, "Hey, I've done this 3 times and I've gotten 3 different answers. What's the right way to do it?" But if you're getting it, 3 out of 3 times, then you're doing it right. Even if you set it up differently than I do, that's not a problem. No one cares necessarily how you set it up. We just want to make sure you get to the right answer. So that's why the setup is important. But and if I don't hear from you, good luck on your test. I know you guys will crush it. Um, and yeah, and have a great semester. You're welcome.